Hello, everybody. Welcome to the first episode of the PenTest Plus Learning Path. Today, I want to apologize up front. Is going to be a little bit different than usual. Most of the time, I'm going to be doing these live on recording going through. This one is not going to be the case because I just downloaded a new thing. Before, I've recorded with an external camera, and that's not connected to the computer at all, just to make it look better. But I thought, if it's just going to be me in the bottom of the screen, it doesn't really need to be that high quality. So I'm just using my webcam, and I downloaded a new software to do that on. And while I was in the middle of recording this, I accidentally hit the backspace key, and my finger slid up and hit F12. And F12 is the key that shuts the video off. So I did this entire room and realized that about 40% of the way through the video, the whole entire thing shut off. So this is going to be a little bit different of a format. I'm basically just going to be talking over what I did, explaining it in a little bit in depth, and going through. I'll still go through all the different things that you're supposed to do throughout this exercise and just show what it is. But so for an introduction, the only thing that you're supposed to do for the first task is basically just deploy and start the machine. So I started the machine already. That is up here. It is already started, and this is the attack box that you will be using everything on. So for an introduction, basically the scope of Nmap and the purpose of Nmap is to provide yourself a view of the network that you're going in. It's nice when you're going in to do a penetration testing engagement that you don't go in blind. And this Nmap is basically the first tool that you're really going to use in an engagement where you're going to scope out the person's network and figure out what type of devices are active. You can also figure out what type of operating systems are active, what versions of operating systems are active. You can create a map of the network when you're using the GUI using Nmap. You can actually map out the network and figure out what's connected to what. Not only can you map specific devices, you can map entire networks. And basically what Nmap is doing specifically, the main purpose of the tool is to show you what ports are open. Now, when you think about common ports, you're thinking about HTTP, HTTPS. Usually, especially when you're first getting started in penetration testing engagements, you're going to be worried about web servers, and you're usually going to find those on there. But the important thing to understand, I'll point out on this graphic right here, there are certain ports that you really should commit to memory, like 443 or 21, 22, 23, 53, 68, 69. All kinds of those earlier ports are very important to commit to memory. These ports over here are randomly assigned ports that are basically just used for listening ports, not something that you're actually going to be sending anything off of. These are all opened for you to connect to 443 on multiple different things, because if you couldn't do that, then you wouldn't be able to browse to multiple different places at once. This is basically just for you to be able to listen to it. So when it comes to the questions, what networking constructs are used to direct traffic to the right application on a server? That is referring to ports, which is what Nmap is scanning. Nmap in total is a port scanning tool. There are 65,535 available on any network-enabled computer. And when it comes to how many of these are well known, if you want to do some further research, you'll be able to find out that that is 1,024, which you would consider those well-known ports. Now, for the switches. So Nmap is run from the terminal, which is like most of them. We can navigate over to the terminal here, and we can just do Nmap-H, and that's just going to pull up an exhaustive list. Now, as we're going to go through these, it can get really time exhausting as you're just kind of scrolling up and down, in like a scavenger hunt fashion. Obviously you can just see them all. I'm just going to go through them quickly and just read them off, explain what they are. Basically, what you should understand from this is that if you're looking to determine Nmap's functionality, you're trying to figure out what it's able to do, what it isn't able to do. you can just type nmap-h and it'll bring up an exhaustive list of all the different switches and things that you can do to use Nmap on. So all of the answers in this section can be found throughout these pages, and you can use all of those rather than spending time scrolling through all of those. Just take my word for it. If you want to do it on your own time, you can scroll through and look. But for a SYN scan, you can use -S capital S. For a UDP scan, you can use -S capital U. Now, understand that Linux is a case-sensitive terminal environment. Not every operating system is. Linux specifically is case-sensitive. So it's important to understand that these cases and everything else, they actually do matter. So if you wanted to detect which operating system the target is running on, which switch would you use? -O. Nmap provides a switch to detect the version of the services running on the target. What is the switch? That's SV. That's another one that I would highly recommend that you think about remembering, especially when you get, towards the beginning of penetration testing. One of the things that you're going to want to focus on is out-of-date operating systems. And out-of-date operating systems, the reason that they're out of date is because usually there's a security vulnerability. Actually, I would say pretty much 100% of the time, an out-of-date operating system, if it hasn't gotten something, it's because there's a security patch missing. The reason that your phones, computers get patches rolled out all the time is because vulnerabilities are discovered. So when you use Nmap and you basically detect versions, if I ran Nmap on a device right now and I found out that it was running Windows 7, well, in my head immediately, just over time, you get knowledge of these things, but there's tons of vulnerabilities in my head that pop up that I could execute on that and get remote code execution capabilities. So there's lots of things to consider from that, but Nmap-SV is one that I would very much recommend if you're going to be using this tool a lot, that you remember that. So the default output provided by Nmap does not provide enough information for a pen tester. How would you increase the verbosity? So basically, this is just saying that you're wanting to get more information from the scan. So it's going to give you some information in general, but if you want more, you can do -V, which will give you more. If you want even more information, you can do -VV, which would give you a double verbosity or set the level to 2 and give you even more information. We should always save the output of our scans. This means we only need to run the scan once, reducing network traffic and thus chance of detection, and give us a reference to use when writing reports for our clients. What switch should you use to save the Nmap results in 3 major formats? So that can be found over there. It's -OA. What switch should you use to save the Nmap results in a normal format, which would be ON? A very useful output format. How would you save results in a greppable format? OG. One thing that you'll notice with Linux too is that it can seem a little bit intimidating at first to learn all the different switches and just navigate a system completely from the terminal. You spend a lot of time in it and you just realize that everything just kind of makes sense. And even if you don't immediately know it, it's just a -help away or just man pages away. But a lot of times they're just basic stuff. You're wondering, what's the greppable one? G. What's normal? N. Just usually it's just going to be the first letter of that, unless it's taken up by something else, and then you'll have a variance. And those are the ones that might be a little bit more tricky to remember. Sometimes the results we're getting just aren't enough. If we don't care how loud we are, we can enable aggressive mode. When it talks about loud, that's basically just talking about being detected by an IDS or IPS system. Usually when you're trying to perform these engagements, you're trying to maneuver around them so that you're not detected. But if you don't care about that, you can enable aggressive mode, which activates service detection, operating system detection, trace route, and common script scanning. And how would you activate the system? Aggressive mode -A. Again, the first letter of that. It's just a simple thing with a lot of command line tools. So Nmap offers 5 levels of timing template. These are essentially used to increase the speed your scan runs at. Be careful though, higher speeds are noisier and can incur errors. How would you set the timing template to level 5? That would be a -T5. There's 6 different ones that you can do. You can do a T-0, I believe. Pretty sure you can. And then 1, 2, 3, 4, and 5. 5 is obviously the fastest, and they're going to, they can trigger IDSs. They could cause an error of some kind. So, not really recommended to do that. But, if you're just playing around, you want to experiment, you can use -T5. We can also choose which ports to scan. So, say that you specifically want to scan only port 80, see if only port 80 is open. That would be -P80. How would you tell Nmap to scan ports 1000 through 1500? That would just be -P1000-1500. Now, a very useful option that shouldn't be ignored, how would you tell Nmap to scan all ports, meaning every single port, literally every single port? That's -P and then just another dash immediately after that. That is how you would explain to scan all of the ports. How would you activate a script from the Nmap scripting library? And there will be a lot more covered on this later, but that is --script. You just type in --script, and then afterwards you use something else. You specify which script you want to run. How would you activate all of the scripts in the vuln category? And that's just --script equals vuln. Now, when we get into the different scan types, so we're going to cover all of these as we get down through it, but basically when you're port scanning, there's 3 basic scan types that you're going to use. You'll use a TCP connect, you'll use a half open scan or SYN scan, or a UDP scan. There are several less common scan types that are also covered in this that we'll go over here. Those are Null scans, FIN scans, and Xmas scans. So most of these, with the exception of UDP scans, are used for very similar purposes. However, the way that they work differs between each scan. This means that whilst the first 3 scans are likely to be your go-to in most situations, worth bearing in mind that other scan types exist. In terms of network scanning, we will also look briefly at ICMP or ping scanning, and that's all covered down under the scan type. So first, TCP connect. So before you get into the TCP scan, it's important to understand what a TCP handshake is. If you don't understand that, I don't mean to be rude to you, but penetration testing might be a little bit high of a grade for you right now. It's very important when you think about penetration testing that you are understanding basic components of networking, and not just basic, but you have a really good understanding of network. You don't have to be an expert, but just that you understand networking. And, the reason for that, when you think about your role as a penetration tester, you are not just somebody, you don't just want to go and get hired by somebody to have them test their network, and then you come with them, and because you don't know how to do anything, you don't actually know how to hack, you come back and tell them, hey, your network's all good to go, you're completely secure, and then you walk away, and a week later they get hacked because of a very simple vulnerability because you just didn't understand what you were doing. And it's pretty hard to get these types of jobs today, so it's not that that's really a situation that would come up a lot, but we need to make sure we're doing our due diligence. And if you're trying to sell yourself as a penetration tester and somebody that knows something, you better understand networking, and TCP is a very foundational thing. But just for the purpose of this lesson, we'll go ahead and just cover what a TCP connection is really quick. So that is basically, say that I am trying to connect to you. I would say to you, I want to connect. And then you would respond back to me, basically saying that you want to connect, and you acknowledge that I want to connect. And then I would acknowledge back to you that I understand you want to connect. And then from there, we can talk and say whatever we want to. The opposite of this would be UDP, which we're going to get into in a second, which would basically be like, before I understand that you want to talk to me, or that you understand that I want to talk to you, I just say whatever the message is. I don't care whether you receive that message, and you don't care whether I, say it. I just say it, and then that's it. And there's advantages to using those types of connections, but TCP is what we're talking about right now. That is making sure that we know we have completely made a connection before we are exchanging any type of data at all. And that is what we're looking for now. So this is a scan that Nmap does, where Nmap will basically send SYN packets and will understand whether or not it is open by whether or not they receive an ACK packet back or whether it receives a reset packet back. Basically, if it receives a reset packet, it understands that the port is closed. If it receives a ACK packet, then it's going to understand that the port is open. Now, the third possibility would be that there's a firewall involved and that it's set to drop the packets, drop SYN packets specifically. This is really useful for trying to defend against a denial of service attack that would just be doing a SYN flood. So there's a lot of firewalls that defend against SYN packets specifically, and they're just set to automatically drop them. So if you send a SYN packet and you receive nothing back, that would indicate that the port is just protected by a firewall, and then it would be filtered is what it would respond as. So when we get down to the questions down below, it would be which RFC defines the appropriate behavior for the TCP protocol. That information is found right up here at the top, RFC 9293. And then if a port is closed, which flag should the server send back to indicate this? That would be reset, or RST for short. For the next one, SYN scans. As with TCP scans, SYN scans -SS are used to scan the TCP port range of a target or targets. However, the two scan types work slightly differently. SYN scans are sometimes referred to as half-open scans or stealth scans. Personally, I don't hear the half-open term used that often. I hear stealth scan used more often. I don't know if that's because people just think it sounds cooler or because it's just the stealthier version of the scans. But either way, that's just what I hear. Where TCP scans perform a 3 full-way handshake with the target, SYN scans send back an RST TCP packet after reviewing a SYN ACK from the server. This prevents the server from repeatedly trying to make the request. In other words, the sequence for scanning for an open port looks like this. So basically, instead of making the full connection, it's going to just send a reset. So sometimes you're trying to not, you're pretty much trying not to be detected by doing this type of thing. And the reason that you would send the reset packet back is so that you don't establish a connection. So the connection, remember, it's a 3-way handshake, isn't established until you that initially send the SYN packet are sending back the ACK packet. That is the moment right here, if this is an ACK packet, that you're establishing the connection. The purpose of this is basically just to figure out whether or not it's open or not. You don't really need to make the connection at this point in time. So you receiving the ACK packet, understand this port is open. That would make you aware that it's open, and then you send the reset packet back, cancel the connection, and then you're not really detected as having an open connection. So the disadvantages, that's basically the advantages of using that. The disadvantages is that you can't do this without sudo permissions if you're working in Linux. So if you're just a standard user and you don't have the ability to increase your permissions, you're not able to do this type of scan. And sometimes unstable services are sometimes brought down by SYN scans, which could prove problematic if a client has provided a production environment for the test. So these are things to take into consideration. And just with penetration testing in general, you have the power with the tools that you use in these types of engagements to cause a lot of damage, so be mindful and be aware of the tools that you're using. You don't accidentally want to completely take a server down that you're not supposed to take down. Sometimes a client might want you to just, hey, go all out and see whatever you can do. Take down what you can, whatever. We want to see the full damage. Maybe that's what you are being asked to do. But if you're not asked to do that, you're just asked to demonstrate vulnerabilities. Just show how you were able to get into a specific system, not take it offline. Think about these types of things. So be mindful of that. So all in all, the pros outweigh the cons, and again, that just depends on exactly what type of engagement you're doing. there are different things to take into consideration. As you go further along, you learn more of these tools, you'll understand what type of scans to do in what types of situations. So those are basically the advantages and disadvantages. These, when it comes to the questions, it says there are two other names for a SYN scan. What are they? That's either half open or stealth. And then for the last one, can Nmap use a SYN scan without sudo permissions? Yes or no? The answer to that is no. That was one of the other disadvantages that they listed. Now, for UDP scans. So unlike TCP, UDP connections are stateless. And we talked about this earlier. That would basically be like if I had a message to you and I just saw you walking down the street, I shouted the message to you. It didn't matter to me whether or not you heard that message. It just mattered that the message was sent. You didn't care whether I sent it. There's no connection that we have. All that matters is that the data was sent. And these are used for like video communications, phone calls, all kinds of things like that. Because you wouldn't want to be driving down the road and then basically you have a buffer. You're losing signal. You're driving through a mountainous area or something. And then all of a sudden you end up losing connection. When you get the connection back, you're hearing what was said to you 5 minutes ago and you guys are just all off path. You know, that wouldn't work well for a voice connection. These are supposed to be just all about time. It's about efficiency and about making sure that the time is more important. With TCP, the delivery of the data is more important. So that there's different advantages to either of them. That's why you do it. So UDP scan is basically for connecting to the UDP ports, and making sure whether they're open or not, and being able to figure out that and map that all out. So UDP, this can take a lot more time. It uses it in a different way. So when a packet is sent to a UDP port, there's not going to be a response. There shouldn't be a response because it's a connectionless protocol. All that matters is basically that that is being received. There's no type of connection made between either device or system that's making that. So Nmap's going to refer to that as being open or filtered. In other words, it might think that it's open, but it could be firewalled. In reality, there's just nothing. If for some reason it gets a response, then the port's going to be marked as open. More commonly, there's no response, in which case the request is sent a second time to double check. If there's still no response, the port is marked as open or filtered, and Nmap moves on. When it's sent to a closed UDP port, the target should respond with an ICMP packet, which is just another, it's ping. Ping uses ICMP packets. So it's sent back an ICMP packet containing a message that the port is unreachable. This clearly identifies closed ports, Nmap marks as such, and moves on. So due to the difficulty in identifying whether a UDP port is actually open, UDP scans tend to be incredibly slow in comparison to various TCP scans, in the region of 20 minutes to scan the first 10 ports with a good connection. This reason, it's usually a good practice to run Nmap scan with a top ports number enabled. For example, scanning Nmap SU-top ports 20. That'll just scan specifically the most commonly used UDP ports, resulting in a much more acceptable scan time. So you'll find later on, and especially as you get towards the end of this task and the different practical tasks, that some of the scans that you're going to run just to basically get your feet in the water and get your hands dirty and just start to use Nmap a little bit, the scans can take a long time when you start adding in SYN scans or UDP scan or anything like that. So specifically using top 20 ports just to define, hey, we're only going to look at the top 20 because those are just most commonly used. Not really much of a reason to look at the other ones in some circumstances. It can help speed up the process quite a bit. So for task number 8, we're going to look at the Null, Fin, and Xmas scans. So these are less commonly used than any of the others, but they are a little bit more stealthy and even more than the stealth scan itself. So a null scan, you send that by using -SN. So when the TCP request is sent with no flags set at all, and per the RFC, the target host should respond with an RST if the port is closed. So basically, if you send something and then you get the RST, that means the port's closed. So that's the way that that scan works. And if you understand that the port's closed, then you understand the port's closed. If you don't get anything, that means it's open. SF almost works identically, except instead of sending a completely empty packet, request is sent with the FIN flag, usually used to gracefully close an active connection. Once again, Nmap is going to expect the RST if the port is closed. So with the other two, Xmas scans, which you do by typing -SX, send a malformed TCP packet and expects an RST response for closed ports. It's referred to as an Xmas scan as the flags that it sets, PSH, URG, and FIN, give it the appearance of a blinking Christmas tree when viewed as a packet capture in Wireshark. And you can kind of see the example of what it's talking about right there. So the expected response for open ports with these scans is also identical. Basically, if there is no response, then the port is open. There is also an expected behavior if the port is open. So they're going to get the same exact type of thing. You're just going to come back as open or filtered. So you don't get as much information with these, as specific of information as you do when you're using a TCP scan by using either a SYN or just a TCP scan. So something to think about, not as reliable, more stealthy, but not as accurate of information. So which of the three shown scan types use the URG flag? That would be the Xmas flag, and that you noticed in this description right here. Why are Null, FIN, and Xmas scans generally used? For firewall evasion. Which common OS may respond to a Null, FIN, or Xmas scan with a reset for every single port, regardless of what it is? And that would be Microsoft Windows when you're doing that. For the last type of scan that we'll be covering in this room will be ICMP network scanning. So first connection to a target network in a black box assignments. First objective is to obtain a map of the network structure. In other words, we want to see which IP addresses contain active hosts and which do not. One way to do this is by using Nmap to perform a so-called ping sweep. This is exactly what the name suggests. Nmap sends an ICMP packet to each possible IP address for the specified network. When it receives a response, it marks the IP address that responded as being alive. For reasons we'll see in a later task, this is not always accurate. However, it can provide something of a baseline and is thus worth covering. To perform a ping sweep, you just use the -SN switch in conjunction with IP ranges, which can be specified by either a hyphen or a CIDR notation. For example, you can scan the network using 192.168.0.x to network using nmap-sn/192.168.0.1/250 or 1 through 254. Or nmap-sn 192.168.0.0/24. So that /24 is referring to CIDR notation. So what that is basically referring to your net mask and what your network is covering throughout that point in time. So with a 192.168.0.0/24, just knows that basically everything in the 192.168.0.0 network, well, really just 192.168.0 network is going to be scanned. So it's going to scan every single IP address in that range. It'll automatically do that. So for the question, how would you perform a ping sweep on the 172.16.x.x network? And you see that the net mask is defined as 255.255.0.0. So the CIDR notation for 255.255 is a /16. That's a class B address, and that would just be nmap-sn 172.16.0.0/16. Now, the last big thing that's going to be covered with Nmap in this room is scripts. And scripts isn't really something that I've done a ton with Nmap. I don't think it's something that I personally will ever use that often, because there's just a lot of other things that you can use scripts for that are more efficient. But Nmap scripting engine is definitely something that you can use. And if you really want to save yourself some time, I guess you can think about these things and some of the stuff that Nmap's already got in it. So the Nmap scripting engine is an incredibly powerful addition to Nmap, extending its functionality quite considerably. NSE scripts are written in the Lua programming language and can be used to do a variety of things, from scanning for vulnerabilities to automating exploits for them. The NSE is particularly useful for reconnaissance, however, it is well worth bearing in mind how extensive the script library is. There are many categories available. Some useful categories include safe, intrusive, vuln, exploit, auth, brute, and discovery. And you can find a more exhaustive link on this link right here. In the next task, we'll look at how to interact with NSE and make use of scripts in these categories. So what language are the NSE scripts written in? That is Lua. And which category of scripts would be a very bad idea to run in a productive environment? Intrusive, because these are not safe and they're likely to affect the target. So especially in a productive environment, you don't want to destroy anything because they're in the middle of trying to build something. That would not be a good thing to do. So in task 3, we looked very briefly at the -- script switch for activating NSE scripts from the vuln category using -- script equals vuln. It should come as no surprise that the other categories work in exactly the same way. So if the command -- script equals safe is run, then any applicable safe scripts will be run against the target. Only scripts which to target an active service will be activated. So if you're trying to run a SMB script against an FTP server, well, nothing's going to happen. So to run a specific script, we would use -- script and then the script name. For example, that right there that you see out here. I'm not going to read a bunch of URLs off when I'm going through this. So multiple scripts can be run simultaneously in this fashion by separating them with commas. For example, script equals, here's a script, comma, here's another script, and then both of those will be run. Some scripts require argument, for example, credentials if they're exploiting an authenticated vulnerability. These can be given with the -- script args. Nmap switch, an example of this would be the HTTP put script used to upload files using the put method. This takes 2 arguments. So if you're going to run the script, you're going to need the URL to upload the file to and the file's location on the disk. So this is an example of what that syntax would look like. So you got nmap -p80. So this is trying to get to the HTTP port. The script specifies HTTP put, and then the arguments necessary, HTTP put, URL, what the URL is, and then this is what the file is right there. You run that and it'll upload that file to that specific URL. So arguments are separated by commas and connected to the corresponding script with periods. For example, script name and then dot argument. So there is a whole list of scripts in this link. If you want to check that out, you can do that. And if you go to that link, you can basically look for scripts, or you can do it over in the command line, which we will do in a moment in the next task. But for ftp anon.nse, you can find this information on nmap.org if you like. And the optional argument that you can use for ftp anon.nse is max list. Now, when it comes to searching for scripts, so there is a way to do this. You can either do it on Nmap's website, which is a very useful website that's got a crazy amount of information covering every little ounce of the program. It's a really useful website. I recommend, if you're looking to learn even more beyond the scope of this room, that is the place to do it. But we're also able to do the exact same thing on our local machine. So if we switch and we go to this directory, which is cd, well, you're going to cd to your user directory, and then you've got a couple other ones. Just let me get all the way there. Okay, so you're going to the user share nmap scripts. So all of these scripts are stored in this directory by default, and when you specify a script, this is where Nmap is going to look for the scripts that you specify. If they're not there, you move it to somewhere else for some reason, Nmap isn't going to be able to find it unless you eventually tell it that it needs to look in a different area. So you can search for them in a couple different ways. One of them is using the script.db file. Despite the extension, this isn't actually a database so much as a formatted text file. It's just containing file names and categories for each available script. So Nmap uses this file to keep track of and utilize scripts for the searching engine. You can also grep through it to look for specific scripts, which is a really useful thing. Grep is a tool that you really need to familiarize yourself with as you're going through. It can help speed up stuff significantly. So the second way to search for scripts is basically just to use the ls command, and you could do the same you get the same results by just doing ls-l, and then it gives that, and then you also just get the permissions written off to the side of it, which isn't really important or relevant to this at all. So notice when you're doing it that way though, you need to use the asterisk on either side of the term, which is basically just saying that as long as FTP is in there, it doesn't matter what's off to this side of it, it doesn't matter what's off to this side of it. It's just if it has FTP in it, pull it up. And that is what the command does right there. Now, the same techniques can also be used to search for certain categories of script. For example, you're going to graph safe. So these are all labeled as safe, and you can see over here, safe, 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 safe. Every single one of those is safe. That's why it pulled it up. So if you need to install new scripts, this would be it. It's pretty standard just to use sudo apt update ampersand ampersand sudo apt install, and then whatever you're installing. Nmap is going to do this. And then it just gives you different scenarios. You know, if you're missing something from the scripts, you can look up a script specifically and install it. You can update the database, whatever. You should be able to find it. And you can even make your own NSE script and add it to Nmap if you want, if you've got the knowledge of Lua. So over here, since we've navigated to this directory, it actually asks us to do a task. And obviously you can get the answer right there if you want. But if you want to see how to do this, you are going to search for SMB scripts in the directory. So let's grep user/share/nmap/script/script.db, and I didn't even specify what we were supposed to grep. All right, let me go back over here. We're going to grep SMB. And now we've got all of the different scripts that Nmap is going to run that pulls up SMB. So we are looking for the file name of the script, which determines the underlying OS of the SMB server. So let's just scroll up until we see something like this, smbosdiscovery.nse. So it's going to ask us another thing about that in a second. So let's just go ahead and copy this. And then we'll come down here and just a real simple cat and then paste that specific thing in there. And this is basically the entire script that is written for that. Now you can scroll up through here, and if you look carefully, you can see that there's something that it depends on. Just scrolling up slowly to make sure I don't miss it. Yeah, so right here, dependencies. So within the script, cat is just a command that basically is just going to print the context of a file. And you can read through it all here. But what you're looking for is the dependencies, which is SMB root. Now, firewall evasion. We've already seen some techniques for bypassing firewalls. You think about stealth scans along with Null, Fin, and Xmas scans. However, there is another very common firewall configuration, which is imperative we know how to bypass. So your typical Windows host will, with its default firewall, block all ICMP packets. I think we touched on that a little bit earlier, but it's talking about it specifically here. It says this presents a problem. Not only do we often use ping to manually establish the activity of a target, Nmap does the same thing by default. This means that Nmap will register a host with this firewall configuration as dead and not bother scanning it at all. So we need a way around this configuration. Fortunately, Nmap provides an option for this, -pn, which tells Nmap not to bother pinging the host before scanning it. This means that Nmap will always treat the target host as being alive, effectively bypassing the ICMP block. However, it comes at the price of potentially taking a very long time to complete the scan. If the host is really dead, then Nmap will still be checking and double checking every specified port. It's worth noting, if you're already directly on the local network, Nmap can also use ARP requests, address resolution protocol requests, to determine the host activity. There are a variety of other switches which Nmap considers useful for firewall evasion. I'm not going to go through all these in detail, but they can be found at this link signified right here in the blue. So the following are switches of particular note. -F is used to fragment the packets, basically make them smaller so that they can travel across and make them less likely to be detected. An alternative would be specifying the exact size of the packets that you want. You can do that by --MTU and then the number, and accept a maximum transmission unit size. So basically you're setting the max size so that it's everything below that, and that needs to be a multiple of 8. You can do a scan delay to basically make it take a longer period of time before it is going to be sent. So if the network's unstable and you also want to evade any time-based firewalls, that might be something that you want to do, is just delay the scan over a period of time. And then bad sum will basically be used to generate invalid checksum for packets. Any real TCP/IP stack would drop this packet. However, firewalls may potentially respond automatically without bothering to check the checksum of the packet. As such, this switch can be used to determine the presence of a firewall. So basically, we're just figuring out whether or not there's a firewall or not. That would determine that for you. So, which simple and frequently relied upon protocol is often blocked, requiring the use of the -PN switch? That is referring to the ICMP, Internet Control Message Protocol. Now, for some external research, you can already see the answer right there. But which Nmap switch allows you to append an arbitrary length of random data at the end of the packets? You can actually go on nmap.org and find the information for this, but it is specifically saying --data-length will allow you to do that specific task. Now for the practical thing. So we are going to head over to our terminal, and we're going to ping this target and see if it responds. So it's 217.253. Pretty much every machine you'll ever use on TryHackMe will start with 10.10. So we're sending these ping packets, and we're getting no response at all. So you can just go ahead and Control C out of there. 10 packets transmitted, 0 received, 100% packet loss. So no, it does not respond to them. So if you perform a Xmas scan, you can do nmap-sx 10.10.217.253, and then you can specify what ports you want to do, 1 through 999. Oops, I think I typed something wrong there. Let's see what I said. Oh, yeah. Remember earlier how I said that Linux is case sensitive? SX is not valid. Capital X is valid. And this will take a little bit of time. But basically, when this scan is finished, you're going to find out that it says that all of the ports are open or filtered. Now, that's extraordinarily unlikely that every single port is actually open. So it says that every single one of them are open or filtered. And so as you can see, the results of it is that it says all 999 scan ports on that IP address are open or filtered. Now, how likely is it that this is actually true, that every single port is open? Well, obviously every single port isn't open. This scan didn't really tell us anything. It gave us nothing at all. So we need a little bit more information to understand exactly what's going on here. So if you remember earlier, you can increase the verbosity. So we can run that same exact thing, but back here, just add in that double V, and it will go ahead and do all this extra stuff. So it's going to load all this right now. It's going through the scan, and it will give us more information this time. That's basically just going to explain exactly what is taking place and specifically why we're not getting any response. And it says all 999 scan ports are open or filtered because of 999 no responses. So the reason that we didn't get any, or the reason that it says that they're all open or filtered is because there's no response. And you remember, that's going to be the default answer when there's something that is filtered like that. Is when you're sending something, you get no response, it's automatically going to label it as open or filtered. So we didn't actually get any information for that. Now, the TCP send scan is going to take a long period of time, so I'm not going to waste my time with it now, since I'm just going back over this now, and you can see the answer right there. There's 5 ports that are open. I believe it was like port 21, port 80, 3389, 125, and maybe 53. I'm not 100% sure. But port 80 was open, and that's going to be something that we're doing later. Also, because of how long this video is, I'm not going to take the time to do all of the extra Wireshark stuff. That's just a participation thing, basically. What that's trying to demonstrate is basically just showing you what happens. So if you perform a TCP connect scan, you're going to be able to look on Wireshark and see the 3 separate packets that happen, where basically I send to you that I'm trying to connect. You say, I'm trying to connect, I acknowledge you're trying to connect, and then I send that acknowledgement back. And at that point, we have a connection established. That's going to show up. And when we're talking about trying to evade a firewall or being sneaky, the less connections that you have, the less likely that you're going to be spotted or detected by an IDS system. So by doing this, that's how you're going to find out that you are connected. Now, deploy the FTP anon script against the box. Now, the way that we do this is Nmap. Oh, let's go ahead and get out of this directory just to do it. Okay, so Nmap, and we're just going to specify port, or no, we don't need to do that yet. 10.10.217.253. We're going to specify port 21, and then -- script, and then equals FTP -anon. We run that script. Basically what that's going to do is going to make the connection to FTP, file transfer protocol, on port 21, and then run the script to basically see if Nmap is able to successfully anonymously log on to the FTP server that's running on port 21. And in just a second, we're going to get the results that it says it's successful as long as everything's run correctly, which I am pretty certain that it is. So that comes up and it says it right there. So it shows that port 21 is open, TCP connection, that it's open, it's running FTP, and anonymous FTP login is allowed. So we were able to get into that. It says yes. And to conclude, we have finished the Nmap room. So like I said, guys, I'm sorry. I really don't like doing it like this because it's really easy, you know, if you're just getting frustrated and just looking for an answer, that as soon as I pop up to the video, or as soon as I click on a new task, all of the answers are just right there. But, you know, video malfunctions. Now I know I have disabled the key on my keyboard that shuts the camera off immediately. But that is the end of the Nmap room. So I hope that this was helpful for you. Nmap is a really useful tool. You would do well to just, spend time literally just mapping different devices, or setting a device up using Nmap. It's also good to actually do that Wireshark stuff and pull up Wireshark and basically scan and capture the packets and see what happens from them, see what comes of them. But Nmap's a really useful tool and something that, especially on TryHackMe, you're going to be using a ton. So familiarize yourself with this. This is very good foundational knowledge for pen testing and TryHackMe and the CompTIA PenTest Plus exam. So anyways, this is a very first long video. If you made it this far, I really appreciate it. Thank you guys for sticking around. Like, share, subscribe, all that different stuff. And I hope that you will stick around for the next video in this series. Bye-bye.